So, I'm going to talk a little bit about exponential growth and exponential decay. And first, I'm going to discuss the function and what it looks like. So, an exponential model has a base of some number raised to a variable. That x or t or whatever variable you decide to use is here in your function notation and here as your argument. Your b, some descriptions of b. B cannot be equal to 1. B needs to be greater than 0. If you were to have b be a negative value, what ends up happening is you flip-flop between the complex plane and the real plane, and we're trying to deal with real plane issues. So the restriction b being greater than 0 is beneficial, so that we can deal in the real world. Now, our a is referred to as our initial value. It is actually our y-intercept. So you can look at that expression, and if it's simple like this, and what I mean by simple, it doesn't have a +3 or anything of that included, you'll have a comma 0 as the intercept. Okay. If a is positive, your range is going to be y greater than or equal to 0. And again, that's assuming you don't have like a +3 or a +4, because what's happening is the x-axis is actually acting as an asymptote. Okay. If your a is negative, then you get a graph that looks like this, and your range will be y is less than 0. Okay. If you have a decay model, then what's going on is your b is between 0 and 1. If you have a growth model, your b is greater than 1. And a decay model, if your a is negative, is going to do this, and in a decay model, if your a is positive, it's going to do this. And again, the intercept is 0, comma a, 0, comma a, 0, comma a, 0, comma a. Now, just a couple of examples just so you can see it, and then I'll make some other videos in a minute. So suppose our b is a half. So this is between 0 and 1, so we're going to have a decay. Now, f of x is equal to 3 times 1/2 t. F of t in t, sorry. So your b value is 1/2 and your a is 3. And you really need to work on or figure out why is it the case that 0, 3 is your y-intercept. And my hint will be, think about t at 0, and what is 1/2 to the 0 power? Well, 1/2 to the 0 power is what value? Okay. Now, you'll see a graph that looks something like this. Downward, and I'm going to say trending, not sloping, but downward trending, and it has a horizontal asymptote at the x-axis, or the line y equals 0. Now, if you had your b to be 2, you'd still have that ordered pair 0, 3 as your y-intercept, but now you have a growth model. That value is larger than 1. Okay? Well, hopefully that's helpful, and I'll add more in a little bit.